Hi guys, it's Dr. Bay, and here's Bugsy, and today we're going to go over ester, amide, and nitrile reactions. So stay tuned.
Organic chemistry,
taught by Dr. Bay.
reaction mechanisms,
Reactants to products.
retrosynthesis,
Target deconstructing.
molecules, spectroscopy, soaring through the sky, triumphantly fly, give rise to the complexity of life, living on a dream across the seven seas, learning about spectroscopy. Organic chemistry.
Carboxylic acids are compounds that contain a COOH group as shown here in blue. Now, if we replace the OH group with a heteroatom like chlorine, oxygen, or nitrogen, then we get a carboxylic acid derivative. The four most common types of carboxylic acid derivatives are an acid halide, acid anhydride, ester, and amide. And we can rank the relative order of reactivity amongst these four carboxylic acid derivatives. In this video, we are going to specifically talk about ester and amide reactions as well as nitrile reactions. There are three ways that we can make esters. The first way is starting with a carboxylic acid and using a strong base like NaOH to deprotonate the acidic hydrogen atom. This forms a carboxylate ion, which is a strong nucleophile. This can then undergo an SN2 reaction with a primary alkyl halide to form the following ester product. Another way you can make an ester is to use an acid chloride, an alcohol, and pyridine to form an ester. You can check out the details of this mechanism in the carboxylic acid derivatives video. And the last way to make an ester is called Fischer esterification. In this reaction, a carboxylic acid is converted into an ester when treated with an alcohol in the presence of an acid catalyst. The mechanism starts with protonation of the carbonyl group to make it more electrophilic. Then an alcohol acts as a nucleophile and attacks the carbonyl group. Then another mole of methanol comes in to deprotonate the hydrogen atom. Then a proton transfer occurs to make the OH group a better leaving group, and one of the lone pairs from OH comes down to reform the carbonyl pi bond, allowing water to leave. Then another mole of methanol comes in and deprotonates the extra hydrogen atom to form the ester product. Now let's talk about various different reactions that start with esters. The first reaction is base catalyzed hydrolysis of esters, which is also called saponification, and this reaction turns an ester into a carboxylic acid. The mechanism starts with nucleophilic attack of the hydroxide ion to form a negatively charged intermediate. Then one of the lone pairs from O- comes down to reform the carbonyl and the alkoxide ion is kicked off. Then OMe- comes back and deprotonates the hydrogen atom to form a carboxylate ion and methanol. The carboxylate ion then gets protonated by an acid like H3O+ to form the carboxylic acid final product. Another reaction is acid-catalyzed hydrolysis that turns an ester into a carboxylic acid using H3O+, and aminolysis turns an ester into an amide using an amine. Esters can also be reduced using a variety of different reactions. To reduce an ester into a primary alcohol, you could use an excess amount of LiAlH4 in the first step, followed by water workup to form a primary alcohol. To reduce an ester to an aldehyde, you could use a reagent called diisobutyl aluminum hydride, or dibal, in the first step, followed by water in the second step to form an aldehyde and an alcohol. And lastly, you could use an excess amount of an organometallic reagent in the first step, followed by water workup to form a tertiary alcohol. So to summarize ester reactions, you could use an amine to form an amide, lithium aluminum hydride to reduce an ester to a primary alcohol, dibal to reduce an ester to an aldehyde, an excess amount of a Grignard reagent to form a tertiary alcohol, and either basic or acidic conditions to turn an ester into a carboxylic acid. Now let's move on to amides. There are two ways to make amides. An amide can be made using an acid chloride and two equivalents of ammonia to form an amide. Or peptide bond formation could be used to turn a carboxylic acid and amine into an amide using DCC or dicyclohexyl carbodiimide. Amides can be hydrolyzed to form a carboxylic acid under high heat through either acidic or basic conditions. Acid catalyzed hydrolysis of amides uses H3O plus and heat to form a carboxylic acid. Base catalyzed hydrolysis of amides use NaOH and heat in the first step, followed by H3O plus in the second step to form a carboxylic acid. And lastly, amides can be reduced to primary amines using an excess amount of LiAlH4 in the first step and water in the second step to form a primary amine product. So to summarize amide reactions, we can undergo hydrolysis using an acid like H3O plus or a base like NaOH to form a carboxylic acid. You could also reduce amides to primary amines using lithium aluminum hydride. And now let's move on to the last functional group of this video, nitriles, or carbons triple bonded to nitrogens. Nitriles can be made by reacting an alkyl halide with NaCN via an SN2 mechanism. Nitriles can also be made by reacting an amide with SOCl2. The mechanism starts with one of the lone pairs on nitrogen, forming a new pi bond, while the carbonyl pi bond acts as a nucleophile to attack the sulfur atom of SOCl2. Then the sulfur-oxygen pi bond breaks to form a new lone pair on oxygen, which forms the Zwitterion intermediate. One of the lone pairs on oxygen comes down to reform the pi bond and kicks off one of the chloride ions. The Cl- comes in to deprotonate the hydrogen atom to form a lone pair on nitrogen. Then another Cl- comes in to deprotonate the next hydrogen atom. The NH bond moves over to form the triple bond, and SO2Cl leaves to form the nitrile product. Nitriles can undergo hydrolysis to form a carboxylic acid as well. Acid catalyzed hydrolysis of nitriles starts with H3O plus and heat to first form an amide, which then becomes a carboxylic acid. Base catalyzed hydrolysis uses NaOH and water to turn a nitrile into an amide, followed by H3O plus and heat to then form a carboxylic acid. Nitriles can be reduced using one equivalent of an organometallic reagent to form a ketone, or nitriles can also be used to reduce to a primary amine using an excess amount of LiAlH4 in the first step, followed by water in the second step. So in summary, a nitrile can undergo hydrolysis to form a carboxylic acid using either acidic or basic conditions, and nitriles can be reduced to a ketone using a Grignard reagent, or it could be reduced to a primary amine using LiAlH4.
Organic.